Hello all. So we're going to keep talking about relations, continuing on in chapter 11. So we're going to have 2 days on 11.2 with two different problem sets. And this is to determine the properties of relations. So get yourself ready for notes, and we're going to talk about the three most important properties that a relation can have, which is reflexive, symmetric, and transitive. Now you may be, these will ring bells because these are also the properties of equality in the real numbers in algebra. So the reflexive property, which in equality just means that x is equal to x, for relations it means that the ordered pair XX is in R for all x in A. So every single x in A, so in this case like A, B, C, or D, every single double has to be in R. For the symmetric property of relations, what it means is that if xy is in R, so xy in R implies that the symmetric pair yx is also in R. So this one doesn't mean that every single mismatched pair has to be in R, but if one is in R, its symmetric pair also has to be in R. The transitive property states that if you have x, y, and y, z in the relation, then x, z also has to be in R. So again, this one is not saying that every mismatched pair, but if two are and the y value here matches the x value here, the other pair is also present in the relation. So a lot of your problems for the next week are going to be, here's a relation, here's a set A, determine if it's reflexive, symmetric, and or transitive. So just break these down into 3 steps. You want to ask them separately. So you want to ask yourself first, is this reflexive? This generally is the one that's easiest to tell. So if I'm looking at this set R, for A, B, C, and D, I've got my double A, got double B, I've got double C. Oh, I don't have a double a D comma D here. And so since we can say the ordered pair DD is not in R, so R is not. Because all you need is one element in A that doesn't have that double ordered pair there. All you need is one counterexample. Now we want to ask if it's symmetric. So when we're looking for symmetric, we're looking for these mismatched pairs. So I've got a mismatched pair here, but its match is there. And I have another one here, but its match is here. Because it's AB, BA, BD, DB. So yes, this absolutely is symmetric, because we have these sets here. We can say A, B, and BA are in R, and BD means that DB is also in R. So it is symmetric. Transitive is the trickiest one to determine because you're looking for 2 mismatched pairs to begin with. So in this case, we have AB, and we're looking for another one that has B as its X value here, and is still mismatched. So it's not these two. This transitive property would imply A is here, which it is, because then you'd have A and A together, which is good. The other pair that meets this requirement is B, D. They're in R. So then the question is AD in R? And we can say no. Whoop, AB is, but AD is not an element of R, so R is not transitive. So all you need is one counterexample to prove that it isn't that property, but you need to make sure that every set is true for if you're saying it is symmetric or it is transitive. You might also get relations on the ordered pairs, and not on ordered pairs, but on integers, on real numbers, on natural numbers, and they'll ask you, is it reflexive, symmetric, or transitive? So here is the relation less than on the set of the integers reflexive, symmetric, or transitive? Explain. Now, as before, you're going to think about this separately. So we're going to start with reflexive. And so then the question is, if XX is in R, then that would mean that X is less than X. This is not true. So less than is not reflexive. Again, symmetric. The idea is, okay, say that XY is in R. Then X is less than Y. So the question is then, is YX in R? Well, that would imply, but then that would say that Y is less than X. This is not true. So then less than is not symmetric. Lastly, transitive. Now we're going to say that XY and YZ are in R. So then X is less than Y and Y is less than Z. That means that X, Y, and Z can be written like so, which implies that indeed X is less than Z. So yes, less than is transitive. Remember, you do need to explain your answers for these problems when asked. If you have a question about the properties of relations, please get in touch and I'll talk